So we have three of us today talking about the DTS working group update. Typically, it has just been me on the stage, but it's good that we have three people and it talks about the progress that we have done. So we have very less time in this session, we'll get started. I'll just briefly talk about what DTS working group is, so that we are all on the same page, and then I'll hand it over to Juraj to talk about the progress we have done so far. Okay, so there are two test frameworks in DPDK. One takes care of the unit test cases. Typically, it's for the libraries that we create, and when those libraries are created or modified, people submit unit test cases along with that, and we run them in CI. So that part looks very good to me at this stage. We also have these applications like test PMD, test event dev, etc., to test the DPDK device abstractions. We have a DPDK test suite, which is a separate repository so far. This is a framework for writing automated test cases. And these test cases mainly are for device APIs. And they make use of these apps like test PMD, etc. So one of the problem that we saw that was happening is we were adding features to the DPDK device APIs, but there were no test cases that were being added. So we had a gap in testing. So we wanted to address that gap. To address that, we created the DPDK working group. I lead this working group in the community. So the goal was to understand the community had some concerns about the DPDK test suite. The goal was to understand these concerns, understand how we can address them, and make sure that when we submit the patches, there are test cases that come along with it. So this is an answer to some of the questions that were asked earlier. So the working group had some discussions, and we collected feedback from the community and so on, and we came up with the proposal. So the proposal was to require developers to submit DTS tests along with the patches that they create. So in order to do this, we needed to include the DTS repository in DPDK repository so that the patches and the test cases can come together. So we made that decision, and we said that, hey, we are going to bring the DTS from its own repo into DPDK. But then we just could not lift it and shift it to DPDK repo because it needed to go through the typical review process that happens in the DPDK community. Okay, so we have been working on bringing in the framework first. So we kind of started, our first patch was merged in 22.11. So that's when we started merging the patches. Now I'll hand it over to Juraj to talk about where we are today in terms of different patches that got merged, the design and things, and then the roadmap. Okay. Juraj, you want to take over?
Okay, thanks, Honnappa. And hello, everyone at the conference, whether physically or watching. The name was not butchered that much. I'm Juraj from Pantheon Technologies, and let's talk about where we are with DTS. The first thing, some terminology and what does the topology DTS support. There are three main components to testing DPDK. A node where DPDK code runs, that's going to be test PMD most frequently. We call that system under test or SUT node. The system under test itself is DPDK plus any devices we're testing, such as NICs. Then a node where we generate network traffic, that's a traffic generator or TG node, and an environment where DTS itself runs, that's the execution environment or a controller. A little note about what a node is. That's anything DTS connects to. It could be a bare metal host, a VM, or a container. In the ideal scenario, the SUT and DG nodes shouldn't be running on the same physical host because they may interfere. They could be running on the same host. It's just not ideal. And if they are, they must be properly isolated and they must use different neural nodes. The controller where DTS runs also should run on the same physical host as the SUT node, the same reason. But the controller could run alongside a traffic generator. In that case, it doesn't interfere with DPDK, and the impact on the traffic generator is likely negligible. Okay, next slide, please. So this diagram depicts the three nodes. We have the SUT node, the TG node, and the execution environment or controller running on an execution host. The controller must be able to connect to the DG node and also the SUT node. An important thing in this diagram is the next step that we're testing must have at least 2 ports. There could be multiple NICs. The diagram depicts just one. This node, as mentioned, could be on the same physical host, but ideally they would be separated. Next slide, please. So what's DTS workflow like? We have executions and build targets in DTS. The executions define what test to run and what test bed to use, the SUT node, the TG node, and devices such as NICs. Build targets are nested inside executions. They define what DPDK build config to use, but currently we only support different compilers such as GCC or CLAN. Each build target, for example, one built with GCC, one with CLAN, will be tested on the test beds that we defined in the execution, running the test defined there as well. Let's look at the diagram on the right, which spelled this in more detail. So going from left to right, the user runs DTS. The first thing that happens is the DTS runner loads the configuration where we define the executions and the build targets, and then DTS just goes in loop through all the executions and build targets inside the executions. What do we do in an execution? We just connect to our nodes, or we use the nodes if they were used previously in a previous execution. And on DG node, we set up the traffic generator as part of the node initialization. We also optionally set up huge pages on both the SUT and TG nodes, and then we record the result of this whole setup. Record everything, all the different setup steps, the test cases themselves, and the turn-on steps as well. So this happens on an execution level. On the build target level, we just build the DPDK. Once we have built the DPDK, we run the test suite and that were defined in the execution using the SUT and TG nodes in the process. We run all of the tests. Okay, next slide, please. Let's talk about DTS architecture, starting from the top of the diagram. I mentioned the DTS runner in the workflow diagram. So this class is responsible for running everything, the executions, the build targets, and the test suites. It uses the configuration from a file, which, as already mentioned, defines the execution, the build targets, and the test bed as well. The user can also pass some command line arguments or use environment variables to modify some of the framework behaviors, such as timeouts. So the first thing we do in a DTS run, we connect to the nodes. We work with them all the time. The SUT and DG nodes, these are distinct nodes with their own separate purposes. The SUT nodes are responsible for running all of the DPDK stuff, the DPDK server. The DG node is all about traffic generators, but both nodes share a lot of common code which resides in their superclass node. The common code is about maintaining sessions and defining what happens in the build target and execution setup and takeout. I mentioned connections. We connect to the nodes. The actual connections are implemented in the remote session class. It's in the bottom left corner, or the subclasses of remote session, because the remote session class itself is an abstract class which just defines the interface. And we have an SSH implementation in DTS. Currently, there could be other protocols implementing the remote session, such as Telnet. The remote session only knows how to send a command and then get back the result from the execution of the command. Doesn't know anything about the underlying operating system. For handling interactive sessions, so interactive applications such as SPND running in interactive mode, we have separate classes to write of remote session, interactive shell, Python shell, and SPND shell. So how do we handle different operating systems? Since DPDK supports a variety of OSs, that's the OS session abstract class between the SCT node and remote session. It serves as a adapter between OS agnostic method calls from a node and actual OS specific commands that are sent to the node. We currently just support Linux. There's incomplete support for POSIX, and it's straightforward to have support for other operating systems such as Windows. We have two types of traffic generators that the DG node will be using in the future. For now, it is using just the capturing traffic generator. That one is capable of sending traffic, but also receiving the actual packets and looking into them. So that we can interrogate them and verify the traffic completely. The regular capturing traffic generator doesn't capture packets. It's just going to be counting the number of packets, which is sufficient for performance testing, but for functional testing, we need a capturing traffic generator. So far, we only have an implementation in the form of SCAPI traffic generator, which is a capturing traffic generator. So we can only do functional testing for now. There are two last parts that are worth mentioning. We have the DTS result class. As mentioned in the workflow, after each setup and teardown, and each test case execution will record the result. This is done here, the DTS result, and the subclasses of DTS result, which are not depicted here. And then the test suite class, that is the bread and butter of DTS test suite and test case development. Ideally, the test suite developer will only work with the test PND shell class, and this class, just calling its methods, or developer-defined methods in a subclass of test suite. Or maybe they will also be using SCT or DG node objects, but that is the intention. We don't want test suite developers delving into all the rest of the code if that can be at all avoided. Okay, next slide, please. What do we want to do going forward? We have some immediate goals for 2023.11, which are documentation, API documentation generation, in general documentation. Once this is in place, any future additions to both the framework and the test suites will be required to be properly documented. We're going to add more traffic generator features related to packet manipulation and verification. We're going to add a scatter or scatter test suite. This is one of the most frequently used test suites in the original DTS. And we also want to add a Docker file for the DTS environment, which simplifies DTS setup. That's the immediate goals. We have other goals for the future. We want to add features that are required to run a variety of test suites. We envision that the additional features will be handled mainly by the DTS core developers, and we want to get the framework to the state where anyone from the DPK community would be able to submit test suites without any serious problems. And we currently don't have support for performance testing. This requires support for traffic generators which are fast enough, such as T-Rex, along with features related to these traffic generators. We also want to add parallel functional testing, which is godsend as it saves a lot of testing time. And we're also thinking of adding test case skipping based on tested capabilities. So if we're testing a NIC which doesn't support a feature that the particular test case we want to test, that test case would just be skipped. All right, so that's everything from me. So let me hand this down to Patrick.
All right, thank you, Yuri. I'm glad to move on from being your slide monkey. So I'm Patrick from the Community Lab. As I guess you definitely know from Aaron now, we run CI testing on new patches submitted to DPDK. And one of the tools which we use for CI testing is DTS. So one of the tools which we use is DTS. So I'm going to talk briefly about the 50,000 view of how we do CI testing. I won't spend too much time on it. You kind of just got that from Aaron. And where DTS fits in, and most importantly, what we want to see going forward from DTS development that might make operations better in the community lab and also in other labs too. So the community lab continuously integrates new patch series to DPDK main and next branches. We report any apply or build failures. Then we run a bunch of testing unrelated to DTS. So that's compile testing, unit testing, a little bit of stuff using the sample apps. And then we run DTS. So we use that for testing on a broad set of hardware, which we're hosting at the lab, checking for performance and functional regressions. So the functional regressions are kind of self-explanatory. We're testing for some function in DTS, and if it fails on, say, a particular NIC, we report a failure. And for performance testing, what we do there is basically what we're running in the lab is a single core forwarding test, and we periodically run that for, like, say, a particular branch and like a particular environment and NIC. We store that baseline, and then as subsequent patches come in, subsequently we run that same test and compare against that baseline. If there's greater than 5% delta, we report a failure. Okay, so this is a quick graphic. A new patch series comes in, or we are doing periodic testing. We kick off our testing tree, but as you can see, we run DTS. We have x86 and ARM-based CPU servers in the lab. We've got NICs from Broadcom, Intel, NVIDIA. We publish functional and performance results, set a baseline only if it's one of our periodic tests, and publish to Patchwork as Aaron has described. Here's an example of what one of those forwarding reports would look like for a particular environment NIC combination. So what we'd like to see coming up from DTS that might make lab operations better. We do have these situations where we've got, say, a server with 3 or 4 NICs in it, and then we're running performance and functional tests for each of those NICs, and that all happens serially. So this has begun to cause a small testing capacity problem. So one thing we can do, say, which we've discussed, is spin up containers on like a per NIC basis on the set, and run functional testing in each of those containers at the same time. So that's still testing happening in serial for each NIC, but it's doing some parallel testing on like the server level. This may greatly help our capacity concerns, which will become a bigger concern as we expand our test suite coverage, which we want to do, and hopefully we will be able to do as developers submit new test suites alongside their patch series, adding features, or like Aaron said, for use cases of DBDK that should have some test coverage. We'd like to see a dynamic selection system going forward, so selecting test suites based on what part of DBDK was touched in a patch, and considering information about the environment which we're running on. And in the lab, we'd like to, going forward, act as a responsive, stable proving ground for new introductions to DBDK and DTS with a broad set of hardware we're hosting. And to that end, we did get a smoke test suite merged in 2307. We'll be running that in CI testing this fall and hopefully adding in more test suites as they become available. In conclusion, please join the CI meetings every other week that Aaron mentioned. You can reach out on the CI mailing list and Nathan will add you to the call. Please engage with the DTS group on the various mailing lists. We really would appreciate having more acts, more reviews, and a broader set of people with different perspectives contributing. And that's our contact details. Thank you.
A quick question. It looks like most of the tests, I'm working at NVIDIA. I don't know about Intel, but we have something similar to this. And we're testing most of the feature. Is the plan to integrate the company CI, the private CI from the companies to this? There is no real use case why the developer should put another test if it's already implemented in the company CI, right?
Yeah, I think it goes back to the earlier goal that we set out, right? We want to make sure that we are accepting patches along with test cases. So I can say I wrote 110 test cases that covered 10 lines of code, but I wrote 100 lines of code, right? So we want to have something in the publics that's verifiable, that's available for anybody to look at. So I think that's when we're going to get the confidence. So we would like to have something in the community that anybody can see.
Yeah, I fully agree. But in some companies, for example, where there is a developer and there is a different guys that working maybe in a different time schedule that develop the test, it basically duplicates the work. And
sure,
so
either
you're not accepting patches or you're delaying them.
Yeah, I totally agree. I think this question has come up before. It is going to cause some issues with the workflow the companies have. I think it varies from company to company. For example, in my company, developer, tester is the same person. So yeah, I think there needs to be some adjustment that needs to happen because of this.
Thank you.
What traffic generator do you use for performance test? And do you hear about the DPOF, network load tester? Thank you.
If you can just hang up there. We use T-Rex for performance testing, and do you mind just repeating the second part of the question?
Do you hear about DPOF?
Yeah, we've not worked with that, no.
Oh, okay. I would like to recommend you to use this. I will talk about it next day.
Let's chat about that after. Thank you.
So is it a DPDK-based testing application?
Yes.
Okay. So maybe we could think of hosting that on dpdk.org.
Yeah, that's already done.
It's already done, okay.